Okay, so this is our second day of trig. The worksheet's called 4.1, worksheet 2. And this will be the first day that I am gone, enjoying the lovely weather somewhere else. And I am recording this video just as a quick lesson. It's not meant to be the whole lesson I would do in class. But this is just a quick description of how you would do this kind of problem in the worksheet. So, first of all, what does 30 degrees look like? Well, here's 30 degrees, 60, 90 degrees. Okay, so 30 degrees is about like this. So what is that in radians? Well, we have a handy conversion. We know that pi is equal to 180 degrees. And so we can multiply by a little factor here. And it's really not that complicated. If you want to change from degrees to radians or radians to degrees, you just have to use this pi and 180 in the right way. And so you either multiply by pi over 180 or 180 over pi. Now the 180 is in degrees, right? So why did I use the pi on top here? Because I wanted degrees to cancel. When the degrees are gone, then I'll have radians. Now, radians are kind of weird and they have no unit. They don't have like a little symbol for radians. You know, you don't write RAD after it or anything. So this degree symbol is telling me that my degrees need to cancel each other. There's one on the top, there's one on the bottom. So now by multiplying this way, my 30 can cancel with my 180. I can say 30 goes in here once, and 30 goes in here 6 times. And so now what's left? Well, I have 1 times pi on top, and 1 times 6 on the bottom, so it's pi over 6. Now, it'd be really smart for you to just memorize this, that 30 degrees is pi over 6. Okay? It's something you can just memorize. Because the cool thing is, then, think about this. If you want 60 degrees, and you've memorized that 30 degrees is 1/6 of a pi, then this is going to be twice as much. 60 degrees would be twice as much. It would be 2/6 of pi, okay? Otherwise known as pi over 3. So anyway, if you just memorize that 30 degrees goes with pi over 6, that's the same as 1 pi over 6, that'd be really smart. Just like memorizing that pi goes with 180 degrees. Okay, so pi radians is equal to 180 degrees. All right, anyway. The next problem, let's go to that 120. So do you know what 120 looks like? I do. 120 degrees, this doesn't look like that. Hold on a second. That's 180 degrees. So let's see, that would be 90, so it's between 90 and 180, right? Well, 120 is going to be something like this. All right, 120 degree angle. What would that be in radians? Well, a radian is like 59 degrees or something crazy like that, so we don't want to do a conversion like that. We use the simple multiply technique. So you either multiply by pi over 180 or 180 over pi, and it's easy to forget. Just remember that you want these degrees to cancel. So you need the other degrees, 180 degrees, to be on the bottom. So it has to be pi over 180. And then the smart way to do this is do canceling. What goes into 120 and 180? 60 does. 60 goes in here twice, 60 goes in here 3 times. So this is 2 pi over 3. Would I memorize that 120 is 2 pi over 3? Probably not. I probably wouldn't. I'd probably memorize 60 degrees is pi over 3, though. That would be really smart, because then twice that much would be twice this much. Twice pi over 3, which would be 2 pi over 3. So that's a way you could do it via memorization. But what you really need to know is to multiply by. And what do you multiply by? It's pi and a 180. Just try to remember those two things, and then you probably won't mess that up. You'll probably remember to put the 180 on the bottom so that the degrees will cancel the other degrees. And then what goes into both of these? Let's see, 30 does. 30 goes in here 6 times, 30 goes in here 7 times, so that's 7 pi over 6. Okay, hope you're getting the idea there. Let's go from radians to degrees. So same deal I was telling you, we can use that 180 and pi deal. So if I do 180 over pi this time, why did I switch it around? Because I want the pi's to cancel, so that I'll have just degrees left. So this is 180 degrees over pi. Now, what do I have left? 180 over 6. No, you can't just leave it that way. You got to reduce. So you go, okay, what goes into both of these? Let me see, 6 does. 6 goes in here 30 times, and 6 goes in here once, so the final answer is 30. And do you remember me telling you that it might be smart to memorize pi over 6 was 30 degrees? Haha, it is. All right, pi over 4. If you don't have it memorized yet, you probably should memorize it. Pi over 4, I'm going to start by multiplying by 180 over pi. Why? So my pi's will cancel, and I got 180 over 4, and then I can reduce that. Well, if I wanted to know 180 divided by 4, I might first want to think about, how about if I said, I'm going to split them both in half and say it's 90 over 2. Would that help you get the answer? It would help me get the answer. It's 45. And it's 45, notice there's degrees there. Degrees, 45 degrees. All right. What if it's just something like 2? That's kind of cryptic. How do I change that? I'm supposed to change it to degrees. What on earth is 2? 2 what? Is it 2 pi's? Is it 2 degrees? It's just 2. Well, I guess to start with, you're going to take your 2, and I'm going to continue with this technique of multiplying by 180 over pi, or pi over 180. So I'm going to make it into a fraction. I'm going to say 2 over 1. And I'm going to times it by some fraction. And now, should I use 180 over pi, or pi over 180? Now, this is not degrees right now. If it was, I wouldn't need to do anything, because the point is to convert it from radians to degrees. All right? So if I want to get this one, I'm going to have to multiply by not putting the 180 down here, because that would be implying that I want to make the degrees cancel, and they're not going to cancel that way. I need to put the 180 up here and put the pi on the bottom. All right, so now my degrees is in my answer. See, nothing's going to cancel that off. And so my final answer would be 360 degrees divided by pi. Now, that might freak you out a little bit until you realize that pi is just a number. Pi is 3.14. And so if you really want this final answer, you could just take 360 and divide it by 3.14. Now, we're rounding there a little bit, so our answer isn't exact anymore. But that would tell us exactly how many degrees that is. Okay, so basically, if we, generally speaking, take 360 and divide it by 3, that'd be about 120. All right, so it's not going to be exactly 120. It's going to be, let me think, a little bit less than 120. And that makes sense, because if a radian, 1 radian, is a little less than 60 degrees, it's like 59 or so degrees for 1 radian, 59 point something. Then 2 radians, because it says it's in radians, 2 radians is going to be about double that, okay, which is about double 59, which is about like double 60, which is about 120. And so, anyway, I showed you how you could get this down to 360 pi. All right, there's some about 8 minutes worth of help on that. On the back side, we have, or the next section anyway, it says use the arc length formula to find the missing information. Hopefully your teacher has showed you what the arc length formula is. S equals theta r is a good arc length formula. And it only works, though, if it's in radians versus degrees. So what I'm trying to say is use this formula only if you have radians, or if you want to get radians for your answer. Now notice, all of the ones that we've given you here don't have any units, and therefore they are radians. Okay, they are not degrees. Okay, I just paused and I came back because I want to make sure, yes, these are not meant to be degrees. These are meant to be radians. So 25 radians is really a huge number, because 1 radian is like 60 degrees. So if I'm going to go around 25 radians, if that's like 1 radian, and then like going 2 radians is like to here, 3 radians is all the way open to, it's almost pi. 3 radians is almost 3.4, it's almost pi radians. Anyway, so this would be like 3 radians. 25 radians is like going around and around and around and around in a circle. So that's kind of a rough one to start with, because it's hard to like visualize what we're doing here. So I'm actually going to start with number 27 to make sure you get this kind. Look at number 27 here. And I'm going to try to draw the picture. S is our arc length. R is our radius. And theta is the angle that we have. All right, so I can just picture this number 27 a lot better. So there, you think of it in the context of a circle. Okay. dot in the center of my circle, and my radius they don't give me this time. So I don't know how long this is, but it's r. And they do tell me my arc length, and that would be, the arc length is like this distance here. They do tell me that is 1.5 feet. 0.5. We usually don't even label that though, because it just gets messy. So I'm just going to say that's 1.5. And now, my theta, my angle, is pi over 4, or 1/4 of a pi. Okay, so if I'm going to put that on here, 1/4 of a pi is like this. Because hopefully you remember a whole pi would be like from here to here, it'd be 180 degrees. That's one whole pi. This would be a half a pi. So this, go back here, that would be 1/4 of a pi, right? So this angle right here is 1/4 of a pi, or pi over 4. And what our little formula tells us is S equals theta r, and what is S? S is 1.5. Theta is theta. Do I know my theta? Yes, I do. It's pi over 4. Times the radius. Do I know the radius? No. So now you really don't even have to have this picture. I just wanted to make sure you understood why we're doing this, because we just really need that formula and plug in the numbers in the formula, but I want you to be able to see it as a picture. So when it's all said and done, I solve for r. I figure out what the radius is, because that's what's empty here, this box here, where this is supposed to be the radius. So I'm going to times both sides by 4. 4 times 1.5, 6 is equal to pi times r, and then I'm going to divide by pi on both sides. You might be tempted to use 3.14, but don't, because you'll just be making your answer less accurate. So r is equal to 6 over pi. I'm going to put it over here. 6 over pi. All right, what did I just figure out? The radius, this length of my circle, where I had my dot here, and this is my radius, and then this was 1.5, and then this angle was pi over 4. I figured out my radius here is 6 over pi. Now, if I take 6 divided by 3.14, it's about 2 point something, is how long this radius is. Okay, but exactly 6 over pi. All right, so that's kind of some background. I probably gave you more than you needed, but you just mainly need to use your formula S equals theta r on these problems. And as long as you have your formula, or your problem is in radians, this works fantastically well. Okay, so if I grab a different one, let's say you can grab a weirder one, like this 25 radian one. All I got to do is plug in the stuff I know. S I don't know, so I put S. Theta is 25, so I put 25. R is 2, so I put 2. So S must equal 50. Duh. I may not even know what's going on, but I know that the answer is 50. Now, if I know that this is the arc length, what it's really saying is if I have a radius of 2, and I go around and around and around the circle, 25, not 25 times around the circle, but 25 radians, which would mean go around the circle quite a few times, this radius of 2 inches, going around the circle here, that arc length is going to be like overlapped and overlapped and overlapped. And if I go a whole bunch of times, it's a whole bunch of sets of circles, and they will add up to a total length of 50 inches. All right. If you're not understanding that, just use the formula, plug in the numbers for now. All right. One more kind. Let's do a kind where they give you degrees. I don't have one up here. Let me see if I have one on the next slide. Nope, I don't. If I had one with degrees, I would simply need to change it to radians first. Because if it says like 75 degrees, I can't use this S equals theta r formula. And if I can't use that formula, I don't know how to do it. So my first thought is change this into radians. How do you do that? I just did a bunch of those on the other side of the sheet. So you just have to use that 180 over pi, or pi over 180. Pi over 180, because I want the degrees to cancel. And now I would change my 75 degrees into 75 pi over 180. And if you want to reduce that, go ahead. But that now can go into my formula, but that's radians. So if it's in degrees, you got to change to radians first. But then what's in radians, remember it goes there for the angle. All right, moving on. The central angle, theta, intercepts arcs S1 and S2 on 2 concentric circles. with radii R1 and R2 respectively. Find the missing information. All right, so if I'm trying to do this problem right here, then I got to draw my picture. I got two concentric circles. That means circles that are inside other circles. All right, and do you get them to have two radiuses? This is going to be the first radius. I will call R1. And if that's R1, it goes with, let's say that again, we've got arcs here. So let's draw this imaginary line here that's going to make our angle. Radius 1 just goes from here to here. Radius 2 is our bigger radius, and so that must be the longer one. So that's like radius 2 goes, that blue line there. That's like R2. Okay, so our little circle has, let's say the green one will be R1, and then the blue one is R2. And that goes with the arcs. The smaller of the arcs is going to be called S1, and the bigger of the two arcs is going to be called S2. So then this little arc right here, I'll make it in black. That would be S1, and then I'll make this last one. What color do I have? I don't have any colors left. Yes, I'll have to make this also in black. This one here is going to be S2. Okay, so that's what we're talking about for this picture. Now I'm going to actually slap in the numbers that I know. I know that R1 is 11. Okay, so this little green line right there, that's 11. Next is S1, which is 9. This one right here is 9. And the next one is, they tell us R2 is 44. The blue one there, that's 44. And what do we want to know? We want to know theta, which is this angle on the inside here, the central angle. All right, that's theta. And we also want to know S2, which is this guy right here. I don't know what it is. Well, how can I do that? Well, it's, let's see. We're going to have to set up, using S equals theta R, a little proportion. Actually, probably not a proportion. I'm just going to use the formula, S equals theta R. I'm going to start with the smaller circle here. And I'm going to say this radius here of 11, radius right in there of 11, goes right there, 11. Do I know theta? No, they didn't tell me that. So I'm going to figure out theta is right. Do I know my S that goes with that? Yes, this is the S rate that goes with that. So 9 equals theta times 11. So what's theta? Theta is, divide both sides by 11, 9/11. So therefore, if theta is 9/11, I already got my answer right here, 9/11. Now that'll tell me how to figure out this one. I set up my S equals theta R again, and I now know that for the big picture, for this one, I need to use this radius, that's 40. And my theta, I just figured that out. My theta is right here, 9/11. And my S, I don't know, but I can figure it out by taking this like this. And that tells me that, which I can put right there. Okay, that was a lot of work to do that one. Next kind, to the nearest inch, find the perimeter of a 10-degree sector cut on a circular disc, radius 11. I really recommend you draw a picture anytime you have a word problem. So I'm going to say it's a circular disc, and I want to know the perimeter. And that perimeter is all the way around, you know. And it's a 10-degree sector, right? So that means 10 degrees is pretty small. It's like this. I'll say that's 10 degrees. Sector cut from a circular disc of radius 11. Ah, the radius is 11. Doesn't that look like one of those S equals theta R problems that we just had? The only catch is, the only catch is you can only use this formula if you have radians. You don't have radians. You have a 10-degree sector. Okay, so I got to take my 10 degrees, change it over into radians. So that little technique we've taught you. And to get this into radians, I got to use pi over 80. So my degrees cancel each other. And then 10 goes into 10 once, 10 goes into there 18 times. So it is pi over 18 radians. And now I can stick the radians in there. Now the formula will work. So S, do I know S? No, that's the point. You want me to know this perimeter of a sector. That means this little part right here, plus this part plus this part. Because perimeter means distance all the way around it, right? Not just this little side right here. But we'll get to that in a second. We need to find this little part right here first. That's S. S is equal to theta, which we just figured out. Radians is pi over 18 times the radius. The radius here is 11. And now I can get my S. It's equal to pi, which is just a number, 3.14, divided by 18 times 11. So now I know my S for my sector. And then for the perimeter of the sector, ooh, this was a tough one. I got to remember, I don't want just that one edge. I want this side and this side and this side all together. So if I blow this up and say, here's my sector, what's its perimeter? It's not just this. That's the S we just figured out. It's also this radius and this radius. All the sides put together, this side plus this side plus this side makes my perimeter. So I have to add them all up. Done. All right, that's all I got for you on that list.